515. There we go. Okay. To finish our binary tree, and this one's going to take a little. This one is a lot of coding. Fair warning. So we're going to continue our construction of binary trees. Namely, we're going to extend our previous implementation so that we have contains, aka does it contain the object, aka search for it. That one should be hopefully straightforward. Delete, we just talked about how complicated that was. You'll probably need to go and research that a little bit more about how to code that up. We talked about it a little, but I want y'all to sit down and figure out how can you find the greatest on the left side and move everything up yourself and then update the pointers. We've done insert in class, so that should at least give you a good starting point about how to work on delete. We have delete and remove. Okay. This should only be one of them. Yeah, remove. Ignore delete. Just remove it, find a value and remove it. Exists in range. Okay. We're going to have two other functions that are going to be a little new. One's exist in range and the other is count in range. Good thing I'm giving you a week on this because it'll take you a little while to figure this out. So exists in range returns true if there's a value in the tree that's greater than or equal to min and less than or equal to max. All right, what am I telling you here? We're asking you, are we out of markers? Oh, here, good. And, oh, we don't have a video camera. Hope I didn't break it. All right, let's see, get that set up. All right, ooh, nice glare. Okay, so what am I asking? Exist in range. So if I have a tree, we'll say, all right, start giving me numbers.
17. 12. 2. 4.
4, 2,
6.
6,
3.
3,
1.
1. All right, give me bigger ones.
54.
54.
9,000.
9,000.
10,000.
Oh, you just had to go there.
10,001.
Okay, we're done with the 10,000. All right. We'll put a 128 here. Okay. Exists in range. Hopefully that's not too glary. There's a 3 right here for all the people at home that can't see. This giant sun is actually a 3. So if I were to do exists in range, and I were to pass in the values, let's go 20 and 90. Question is, does there exist a number that exists between the values 90 and 20 inside of this binary tree?
Yes.
Yes. Which number is it? 54. So the answer would be true for that. Let me go ahead and give you the other corner cases. If I do 17 and 19, it is inclusive, so 17 would be counted, and that would be true. Similarly, if I did 15 and 17, that would also be true. True. Okay, and we got that. Okay, let's let me go into at least some negative cases here. If I were to put in the values, we'll say 208,000. False, there isn't any. Okay. Anyone understand what this function is doing? You're just trying to find if there's a number in that range. Perfect.
And it's a Boolean that we return true or false.
This one's a Boolean, yes. Let me double check just to make sure, but it should be a Boolean.
Function.
Yep, Boolean exists in range. Do that one first. Oh, what's the question?
You could just run your search function in that function, right?
It would be similar to a search. It's going to be a little different because you're not, remember, there's a range here, so you're not searching for a specific number. You're searching to see if one exists between the
So I guess
range.
you could just do it with range,
Sure, yeah. So I'll let you all think about how to implement that. So exist in range just tells you if it exists. Count in range is going to ask you how many numbers exist in this range. So it's an extension over the previous one. That was done purposefully. That was a cute sound. So count in range. Of course, if we give it something that doesn't exist, like 86 and 99, the answer is 0. All right. But if we were to do 1 and 9,000,
2.
all of them except 10,000.
Oh. Right.
yeah. So how many is that?
Oh.
I didn't even count it.
11.
Yeah, I got 11. You got 11?
Mm-hmm.
All right. You'll see what's happening. Obviously, I could also ask -1, 2, 9, 9, 9, 9, 9, 9.
12.
Sure, 12. And then your professor, of course, being the evil man he is, he was going to pass 1 and -1.
How many values do you do? 0?
Right.
So
Is that a valid range? No. Yeah. I'm going to do this.
can 0 be in a binary tree?
Yes. 0 is an integer, yes.
So if 0 was in the array, it would be written to return true. It'd return 1, right?
Well, the range, the minimum is 1, the maximum is -1. Does that make any sense?
Oh, minimum's negative. Minimum's 1?
Yeah, minimum is 1, maximum is -1. Does that make any sense?
No, it doesn't.
No. So just do that check real quick. All right. Any questions? All right. I also added pre-order and post-order to this one. So this lab is a little more extensive than previous ones. But hopefully after you're doing the in-order stream, the pre-order and post-order should be somewhat straightforward here. Okay. The last one is in-order traversal. I'm going to pass you a function pointer. Y'all haven't seen this before. But I told you a pointer can point to anything, so it can point to another function. And the point of this is you're going to do your in-order traversal and call the function that I passed to you on every value inside of the binary tree. And I'm going to explain what function pointers are in a moment. But besides that, it's due a week from today? Yeah, a week from today. Any questions? You got this, Jonah? All right. Okay.